Okay, so far we have studied classful IP addressing, but what is the problem with classful IP addressing? The problem is that in classful IP addressing we can only have three types of networks: class A, class B, and class C. So what if an organization only has 26 computers and that organization wants its computers to be connected to the internet, so it's going to ask for an IP address. Now there is a problem, and the problem is that the smallest possible network in classful addressing is a class C network, and in a class C network we can have 2 raised to power 8 minus 2, which is equal to 254 hosts. So when you request for a network address, or you request for a class C network, you're going to get these many IP addresses. But how many computers do you have? You only have 26 computers. So out of the pool of 254 IP addresses that are possible, you'll only be using 26. You'll only be using 26 IP addresses. What's going to happen to the remaining IP addresses? 254 minus 26, because you have 26 computers, you'll only be using 26, right? So what is going to happen with the remaining 228 IP addresses that have come with the class C network that has been given to you, right? So you just asked for a class C network and you bought this class C network, and now you have 254 possible IP addresses which you can use to assign to your computers, but the problem is that you only have 26 computers. So what's going to happen to the remaining 228? These IP addresses will be wasted. These will be wasted because you don't need them. This problem was realized by computer scientists, and they also realized that if so many IP addresses could get wasted in a single network that was owned by a single organization, then pretty soon the 4 billion IP addresses in IP version 4 would run out. So they came with a different scheme, and this different scheme was called Cidr. Cidr stands for classless interdomain routing. So now let's take a look at what an IP address in Cidr looks like. As we can see that the IP address has been given in binary form. So this is the IP address in binary form, and the IP address has also been given in decimal notation. So we have both the examples given in this diagram. Okay, so this is an IP address based on Cidr. Let's examine this IP address. So even in Cidr, the IP address has two parts. There are some bits that are going to be used for the network ID, and there are some bits that are going to be used for the host ID. So the number of bits that are going to be used for the network ID are given at the end of the 32-bit IP address using a suffix. As you can see on this diagram, I have circled the suffix. So this is our suffix, and these up till here are 32 bits. And what you probably can't see clearly is that this is a slash, right? This is a slash right here. So the first 32 bits, are the IP address, and then there is some additional information that has been given by the suffix. So this suffix tells us how many bits are going to be used for the network ID in this IP address. Please note that the suffix is 8 bits long. The suffix value circled in our example equals 21. This means that in this particular IP address, only 21 bits are going to be used for the network ID. Since the suffix value equals 21, so only 21 bits are going to be used for the network ID. And as you can see in this diagram, the 21 bits have been shaded in brown color. This also means that the remaining 11 bits in the IP address, these 11 bits, are going to be used for the host ID. So the first 21 bits were going to be used for the network ID, right? These were going to be used for the network ID, and the remaining 11 bits were going to be used for the host ID. Please note that in Cidr there is no need for a prefix. Prefix was used in classful IP addressing. So the router could determine the class of the network, and then the router from that would be able to determine the number of network bits in the IP address. However, in Cidr, the router studies the suffix value to determine the number of network bits in the IP address. So there is basically no need for a prefix. Okay, let us take a look at few examples of Cidr based IP addresses. We'll try to work out the network address, the host address, and the broadcast address in each case. We will also work out the number of hosts that this network can have. Okay, in this example, what we can straight away see is that this here is the suffix. So this is our suffix, and this is going to tell us how many network bits do we have. When we convert this suffix into a decimal value, then this comes out to be 26, and this here is our IP address, right? So this here is our IP address, and when we convert these 8 bits, they come out to be 170. When we convert these 8 bits into decimal, these should come out to be 17, and when we convert these 8 bits, these should be equal to 71, and then these 8 bits are most likely going to be equal to 159. So you should try this, you should try converting these, and hopefully the values that I have worked out here have been worked out correctly. So this suffix is telling us that the number of network bits in this IP address are 26. So let's just count 26. These are 8, these are another 8, 16, 24, and then these 2 bits. So these are the number of bits that are reserved for the network. So let's work out the network ID. Okay, what I've done here is I have copied these network bits. I have copied these network bits here, right? And then the host bits, I have deliberately changed their color to green so that we can see that these are the host bits, and the host bits have been set to 0. The host bits have been set to 0. So now what we can do is we can now convert these into a decimal notation. Let's convert this network ID into a decimal notation. So when we convert these 8 bits, they should come out to be 170, and these 8 would be equal to 17, these 8 would be equal to 71, and these 8, when we convert with the host bit set to 0, as you can see, when we convert this comes out to be 128. So this is going to be our network ID. For the broadcast IP address, what I have done here is that I have set all the host bits to 1. As you can see, I have set all the host bits to 1. So let's convert this broadcast IP address into a decimal notation. Okay, when we convert this, this should equal 170, this should be 17, this should be 71, and when we convert this equals 191. So this would be our broadcast IP address for this example. So let us now calculate the number of hosts that this network can have. See, in our example we have 6 host bits. So these are our host bits, right? With 6 host bits, it is possible to have 2 raised to power 6 hosts, which equals 64, and then we are going to subtract 2. Remember, all zeros and all ones, right? All zeros is the network ID and all ones is the broadcast address. So we can possibly have 62 hosts. So this network, in our example, this network will have a total of 62 hosts. Okay, in this second example we can clearly see that our suffix here when we apply weights 1, 2, 4, 8 and so on up till 1 to 8, this is equal to 14. So our suffix is 14. When we convert this, this should equal 24, this should be 32, this should be 99, and these 8 bits should be equal to 158. So this is our decimal notation, right? Our IP address in decimal notation, and here I worked out the network ID. See, in this case we only have 14 network bits, right? So 14 means what? 8 and then 6 here, right? So these are 6, right? And these last two are from here onwards, these last two onwards up till this point, these are the host bits. So what I've done is I've set all the host bits to 0, right? And I only have 14 network bits, and then I've converted these into the decimal notation. So these 8 should be equal to 24, these 8, these, let me do that again. So these 8 should be equal to 24, these 8 should be equal to 32, these 8 should be equal to 0, and these 8 should also be equal to 0. So this is our network ID. Okay, for the broadcast IP address, I have set all the host bits to 1, and when we convert this to decimal notation, these 8 should be equal to 24, this should come out to 35, this should be equal to 255, and these last 8 bits should be equal to 255. So the number of hosts on this network we can calculate from the number of host bits, right? And the number of host bits were 18, right? So these 2 plus these 8 plus these 8, right? Remember, the first 14 bits, this was the network, this was the network address, right? And then the remaining, these 18 bits were our host bits, right? So 2 raised to power 18 minus 2 gives us this value. So these are the different, so these are the number of hosts that we can have on this network.